Good day to everybody. Let's continue our discussion still on chapter 4, resultant of force systems. Our next topic is cross product or vector product of two vectors. Now, our previous topic was a moment of a force about a point. So this topic, our new topic, okay, cross product or vector product of two vectors is still applied on solving for the moment of a force about a point, but now in 3 dimensions. Okay, so 3 dimensions, and your knowledge about matrix or matrices is needed here, especially in the sa pag-solve ng determinant of a certain matrix. Okay, I don't know if you have discussed that before in your previous mathematics subjects, but we need that to perform cross product. Okay, so I don't know, maybe I can present to you, for those who have no idea about how to solve for the determinant of a certain matrix, I can present to you one method, how to solve for the determinant of a certain matrix. So usually we're going to deal with 3 by 3 matrices, and there's a shortcut actually to solve for the determinant of a certain matrix. Maybe you have discussed this before in high school. I think we have discussed before in high school, during high school ako, we have discussed this because this is one way of solving system of linear equations. Gumagamit tayo ng matrices, or yung pag-solve ng determinants, we call it the Cramer's rule. If you can still remember, if you have discussed, of course, that particular topic in high school, but I think you have. You had discussed this. You have discussed it before in high school, or perhaps in engineering. Pre-calculus, I don't know. Hopefully you know. Anyway, I'll try to discuss na lang how to solve for the determinant of a certain matrix. Yung shortcut method na lang, kasi may shortcut tayo for 3 by 3 matrix. Alright? But if you know other ways to solve for determinants, that's fine with me. Okay lang yun. Okay? So, so yung application, as I've mentioned kanina, the application of cross product or vector product is now for us to solve, okay, for us to solve the moment of a force about a point in 3 dimensions. Okay? So, what I want you to note now is yung formula natin to solve for ito yung derivation ng formula natin. Okay, based from the properties of a cross product. Okay, ito yung ating formula for ito yung i-apply natin to solve for the moment of a force about a point. Ito, dyan galing itong formula natin. If you want to solve for the moment of a force, by the way, this is also applied in 2 dimensions, so put it into 2 dimensions. About a point here, okay, it is equal to the cross product of the position vector r and force F in its Cartesian vector form. Okay, so the position vector r is the position vector drawn from O, ito yung point O natin, okay, to any point lying on the line of action of F. Okay, to any point on the line of action of F. So point O to any point on the line of action of F. So depende kung saan, kung nasaan yung kung basta alam natin kung ano yung coordinates, yung along the line of action of F, then we can solve for the position vector R. So ganyan lang. So the moment of a force about O is equal to the cross product, okay, of the position vector R and vector F F, take note that F should be in its Cartesian vector form. Okay, so ito yung ating, so na yun. Ito yung gamitin natin na formula. So, cross product or vector product of two vectors. So, we have vector A and vector B. In this case, dito sa pag-solve ng memon natin, position vector R is here is still a vector, quantity, position vector siya. And F here should be also expressed in Cartesian vector form. So, ganito yung itsura ng ating formula. So, the product of two vectors here is equal to the determinant nito. So, AX, AY, AZ. So, we need to express now A in terms of its vector form. So, alam na natin yan. B in its vector form also. Ayan. And the directions I, J, K. So, ganun lang. The determinant. So, we really need to know how to solve for the determinant of a certain matrix. Okay. So, yan. So, the moment of a force about a certain axis. So, i-apply naman natin yung scalar triple product principle. Okay. So, meron tayong example dyan. Ito. Alright, to solve for the moment of a force about a line or axis. For example, ito yung force natin. Okay. I-solve natin yung moment niya along this axis. Okay. So what we need to know is, i-solve muna natin yung moment ng force about O. Okay. And then, i-multiply natin yung unit vector of the line or axis where we are solving the moment, no, dito sa axis na ito. For example, itong axis na ito, solve natin yung moment of this force along this axis, that's simply equal to ito. Okay, so yung position vector natin, halimbawa, you want to solve for the moment of this force along x-axis, MOX, so that's simply equal to ito kanina, yung moment of a force about O muna tayo, and then i-multiply lang natin yung unit vector along the x-axis. Alright, and so on if gusto mong isolve yung along Y, along Z, or any axis dito. Okay, alright. So, yan. So, vector representation of moment. Ito. So, vector representation along I, J, K directions. And if you want to solve for the magnitude of the moment, so, all the resultant of the moment, the usual way of solving the resultant, ito. Okay? So, that's it. Yun lang ang kailangan natin malaman sa pag-solve ng moment of a force about a point or a certain axis using the principle of cross product or vector product. Okay. Maybe we can explain this further using some examples. Right. Let's solve this example. We have solved this before, in our first discussion. Moment of a force about a point. And let's see kung parehas yung masosolve natin na of course dapat parehas, using the principle of cross product. Okay, determine the moment of the force F. Now F here is already expressed in its Cartesian vector form or vector form about point O. Okay, ito yung ating point O. This is F. Okay, this is 4i plus 80j, in newtons. So, to solve for the moment of the force about point O using the principle of cross product, so sabihin kanina, MO is equal to R cross F. So, we need to solve for the position vector F here is already expressed, given naman na express na siya in its Cartesian vector form. If not, then we have to express F in its Cartesian vector form. Pero expressed na siya, so no need to express it in its Cartesian vector form because it's already expressed in its Cartesian vector form. Alright, what we need to know is the position vector. So anong position vector yan? That is the position vector of the line between point O, where we are summating moments, we are taking moments about, so, and the line of action of F. So, pwedeng nandyan. So, if we try to extend yung F, let's see, pag-extend natin yung F, yung line of action of F, so, pwedeng dito, O, at this point, that point, pwede yan, pwede to, pwede yan, pwede yon, aling point from O to any point along the line of action, ano. But the problem is that dapat kaalam natin yung yung coordinates, no. So we know O, so O is 0, 0, 0, 0, it's the origin, ano. But if you choose this point, we don't know the coordinates of that point, no? So, dapat alam natin yung second point natin, ay alam natin kung ano yung coordinates niya. So, obviously, we will choose this point, ano? Because at that point, we know the coordinates. So, X is, X coordinate is 360. Convert na lang natin sa meters. You may or may not convert it into meters, but convert na lang natin sa meter. So that is 0.36 meters. Y, itong Y coordinate natin is 0.15 meters. Ating Z kasi nasa 2 dimensions tayo. No. So we need to solve for the position vector. Yung position vector natin. OA. So, ROA, yun ang kailangan natin. So, ito, F, alam na natin, given na. So, we need the position vector OA. So, paano isolve yung position vector OA ulit? So, head minus tail. So, we have 0.36 minus 0. So, that's equivalent to 0.36i. And then, 0.15 minus 0, that is plus 0.15j. Okay. Plus 0 k, since lagyan na lang natin, no, para sa may laman yung k natin mamaya sa matrix. Ayan. Okay, so okay na tayo, solve na. So the moment of F about O then is equal to the cross product of ROA and F. It's equivalent to the determinant. Ang symbol for determinant ay ganyan, dalawang bars. Okay. So, that's equivalent to, so ayusin lang natin, ROA, dito, lahat ng coefficients of ROA in its Cartesian vector form. So, I, J, K. So, 0.36. J is 0.15. K is 0. Ayan. Alright. Next, F naman. Yung F natin is given naman na, no? 40. Yung I. J is 80. K is 0. And then, ang mga directions natin ay J, K. So, isolve natin yung determinant ng matrix na ito. Okay? So, how do you solve for the determinant? So, meron tayong there's the usual way of determining the determinants. I forgot the term, but you can revisit your books in algebra. Meron doon, no? Usually, lahat naman ng books, hindi naman siguro lahat, But most of the books in algebra, meron itong ganitong principle, yung pag-solve ng determinant of a matrix. Now, there's a shortcut way of solving the determinant of 3 by 3 matrix. This is only applied sa 3 by 3 matrices. Okay. Okay. Kapag 3 by 3, sabi natin, meron siyang 3 rows and 3 columns. So, we call this the basket method. Basket method in solving for the determinant of a 3 by 3 matrix. Okay. So, ang basket method, ang gagawin natin, itong dalawang columns natin kukopyahin natin. Okay. So, we have 0.36. By the way, sa module nyo yata, hindi na nailagay yung pag-solve ng determinant because ina-assume natin ng mga teachers na since tapos na kayo sa mathematics subjects, basic mathematics, then perhaps you're done with this particular topics. You already know how to solve for the determinant. But I don't know if there are still some of you don't know how to solve for determinant, so I'm going to discuss na lang in detail how to solve for the determinant ng 3 by 3 matrix using the shortcut method, which is the basket method. So sa basket method, copy natin yung first two columns dito. So we have 0.36, 0.15, 40, 80, I, J. Ayan. Okay. So, MO then is equal to yung determinant nila, cross product. So, dahil basket method yung term dyan. So, ito yung, gagawa tayo ng linya, diagonal line. Ito. Ganon din dito. Okay, diagonal. Okay, so gagawin natin, i-multiply lang natin itong mga to. Mga nasagasaan ng diagonal line natin. Okay. So we're going to multiply ito. I'm sorry if I cannot discuss in detail about determinants for those who don't know yung concept ng determinant, but I'll just show you how to solve for the determinant for 3 by 3. Take note, for 3 by 3 lang ito. So i-multiply natin ito. So that is 0.36 times 80 times k plus ito 0.15 times 0 times I, tapos ito plus 0 times 40 times j. Okay? So lahat ng downwards na arrow na yan, multiply lang natin, then add. So add lang natin. Okay. Then minus yung upwards naman na arrow. So, maintindihan niyo na kung bakit tinawag na basket method ito, ano? Okay, so mukha kasi siyang basket. Kaya tinawag na basket method. Ngayon, minus itong products naman ng mga upwards na arrows. Okay, so we have minus to downwards minus upwards. Okay. So we have I times 80 times 0 plus j times 0 times 0.36 plus k times 40 times 0.15. Okay? So obviously, itong term na to ay 0. 0 din yan, 0 din yan, 0 din yan. So, 0, merong multiply sila lahat sa 0 eh. So, 0 yung material lang ito. So, MO is equal to Let me get my calculator. So 0.36 times 80, that is 28.8 K. Minus, I should say, kasi yung subtractive yan. We have 40 times 0.15, that is 6 K. So yung moment natin about O is equal to, so 28.8 minus 6, that is 22.8 K Newton meter, or that is 22.8 Newton meter. So that is the moment of the force about O. Okay? So yan yan. I think parehas naman sila sa una nating solution when we have solved this using we have solved this sa previous video. Okay. So yan, that's how we solve this problem. So cut muna natin. I'll separate video na lang yung ibang examples.